So, hello everyone. Today we're going to be doing a special type of a substitution for integration. So, whenever you have an integral of a rational function in terms of sine x and cosine x dx, one of the easiest ways to solve such integrals, or one of the most powerful ways to solve such integrals, is to use the so-called universal trigonometric substitution. So universal trig sub. Okay, so what is this universal trigonometric substitution? It always has the form of t is equal to the tangent of x over 2. From here, it follows that x is equal to 2 times the inverse tangent of t. So when you differentiate both sides with respect to x on the left and with respect to t on the right, you can actually find that dx is equal to 2 over 1 plus t squared, of course, times dt. Now, what we want to do next is rewrite sine x and cosine x in terms of t. So sine x is equal to sine x over 1, which is the same as sine of 2 times x over 2 over 1. And now, using the double angle formula for sine, in the numerator, we can just write 2 sine of x over 2 times the cosine of x over 2. And by using the basic trigonometric identity in the denominator, we can write it as sine squared of x over 2 plus cosine squared of x over 2. Now, we're going to divide both the numerator and the denominator by cosine square of x over 2. So 2 sine of x over 2 times cosine of x over 2 divided by cosine squared of x over 2. That's our new numerator, over our new denominator, which is sine squared of x over 2 plus cosine squared of x over 2, everything over cosine squared of x over 2. Of course, we could cancel out these two cosines, but that's not what we want. Now, notice that we can cancel out this cosine and this square right here. And we can also then rewrite this as 2 times sine of x over 2 over the cosine of x over 2. And here in the bottom, we can separate these two terms as sine squared of x over 2 over cosine squared of x over 2 plus cosine squared of x over 2 over itself will just give us 1. And finally, notice that the numerator can be written as 2 times the tangent of x over 2, and the denominator can be written as tangent squared of x over 2 plus 1. And remember that we said that t is equal to tangent of x over 2. So this is just 2t over t squared plus 1. In other words, when you're using this universal trigonometric substitution, the sine of x can be rewritten as 2t over t squared plus 1. And this is always true when using this substitution. Now let's go over to writing cosine of x in a similar manner. So that's basically the cosine of 2 times x over 2 over sine squared of x over 2 plus cosine squared of x over 2, which is just 1. Or when using the double angle formula for cosine, we'll get in our numerator cosine squared of x over 2 minus sine squared of x over 2 is over the same thing as in our previous step, sine squared of x over 2 plus cosine squared of x over 2. Again, we're going to be dividing both the numerator and the denominator by cosine squared of x over 2. So we'll get 1 minus tangent squared of x over 2 over 1 plus tangent squared of x over 2. Or when we remember that tangent of x over 2 is simply t, we'll get 1 minus t squared over 1 plus t squared. So in conclusion, the cosine of x can be rewritten as 1 minus t squared over 1 plus t squared, of course, when using this substitution. And the third formula that we are going to need is the one that I showed right here, the one first, dx is equal to that. So just to give you an example, I'm going to solve an integral, and this is a very powerful integration technique, a very powerful substitution. I'm going to now solve the integral of, let's say, 1 over 2 plus cotangent of x dx. So we all know that cotangent of x is simply equal to cosine of x over sine of x dx. And once we rewrite it in a bit simpler form, we'll see that it's the same as the integral of sine x over 2 sine x plus cosine x dx. And now we're going to use, you guessed it, the universal trig sub. So I'm just going to say that t is equal to tangent of x over 2 sine of x. Okay, now dx is equal to 2 over 1 plus t squared. Sine of x is equal to 2t over t squared plus 1. And cosine of x is equal to 1 minus t squared over 1 plus t squared. And of course, let's not forget the dt right here. Okay. Now it's going to be pretty simple. So instead of sine x, I'm going to write 2t over t squared plus 1 In the lower part here, we'll get 2 times 2, which is 4, times t over t squared plus 1, plus 1 minus t squared over 1 plus t squared. And of course, let's not forget the dx, which is simply going to be 2 over 1 plus t squared dt. Okay, now we're going to rearrange this in such a manner that it will be a bit less of a nuisance. So we can add these two parts in our denominator. Okay, so over t squared plus 1. And here, and here we'll get minus t squared plus 4t plus 1, everything over t squared plus 1 times 2 over 1 plus t squared dt. Okay, and now we can nicely cancel out both of these, and we'll get the integral of 4t over the integral of negative t squared plus 4t plus 1 times 1 plus t squared dt. So now we've got an integral of a rational function in terms of t. Okay, so the first thing that we're going to try and do is factor out some constants. Why? Because I don't like constants inside the integral sign. So I'm just going to factor out this 4 right here and the minus from here. Okay, so we'll get the negative 4 times the integral of t over t squared minus 4t minus 1 times t squared plus 1, and of course dt. Okay, now the next thing that we're going to try and do is factor this part right here. This other part is not factorable, at least not in the real world. This here part, it's not factorable. So we're going to go ahead and try and factor this part right here. How? Of course, by using the quadratic formula. So we solve this equation. So t12 is equal to 4 plus or minus b squared, which is simply 16, and plus 4, everything over 2. Okay, so 4 plus or minus b squared plus, okay, so this is equal to 4 plus or minus square root of 20, which can be rewritten as 2 times the square root of 5 over 2. So t1, which is, and of course we can cancel out the 2's here, and we'll get 2 plus or minus the square root of 5. So t1 is equal to minus the square root of 5, and t2 is equal to 2 plus the square root of 5. Or in other words, that means that we can rewrite our original expression, t squared minus 4t minus 1, as t minus 2 plus square root of 5 times t minus 2 minus the square root of 5. Okay, now we'll go back to our integral. So we've got the negative 4 times the integral of t over t minus 2 plus the square root of 5 times t minus 2 minus the square root of 5 times t squared plus 1, which we said that is not factorable, dt of course. So what we want to do is actually to separate these now into 3 distinct parts. So I'll just rewrite this as t over t minus 2 plus the square root of 5 times t minus 2 minus the square root of 5 and times t squared plus 1 is equal to a over t minus 2 plus square root of 5 plus b over t minus 2 minus the square root of 5 and plus c t plus d over t squared plus 1. Now, by multiplying, we're going to multiply the entire equation by this denominator. So on the left-hand side, we're just going to be left with t. On the right-hand side, we're going to be left with a times t minus 2 minus the square root of 5 times t squared plus 1 plus b times t minus 2 plus the square root of 5 times t squared plus 1 and plus ct plus d times these two products. But remember that we can just rewrite them as this. So times t squared as this right here, since that's the same, times t squared minus 4t minus 1. Okay, now I'm going to multiply all of this. So just to make it a bit less time consuming, I'm just going to skip a couple of steps and do it in my head. Sorry. So at times t squared is at to the third, at plus at minus 2at squared minus 2a at cubed plus at minus 2at squared minus 2a minus a square root minus a square root of 5 times t squared minus a times the square root of 5 plus bt cubed plus bt minus 2bt squared, 2bt squared minus 2b plus b times square root of 5t squared plus b square root of 5, let's put down plus here, plus ct to the third minus 4ct squared minus ct plus dt squared minus 4dt minus d. And we're just going to rearrange these parts a bit. So I'm going to use some different colors. Let's start with blue. So here we've got a t to the third. Here we've got another t to the third. And another right here. So we don't have any more b's to the third. So from here we'll get our first equation. So a plus b plus c is equal to 0. Now let's go ahead and use green for the squared parts. Here's one, here's one, another one, another one, another one, and another one. So from this part right here, we're going to get our second equation. So minus 2a minus a times the square root of 5 minus 2b plus b times the square root of 5 minus 4c plus d is equal to 0. Let me just rewrite this in a little bit of a better form. So minus 2 minus the square root of 5 times a plus the square root of 5 minus 2 times b minus 4c plus d is equal to 0. So we'll call this our second equation. Now let's go ahead and use yellow to denote all the linear parts. Here's one, another one, another one, and another one. So from this equation, now we have that a, we'll get another equation, a plus b minus c minus 4d is equal to 1. And finally, we'll get that we only need our last equation, which are these three parts. This one, this one, this one, and this one. So in other words, our last equation will be that minus 2 minus the square root of 5 times a plus the square root of 5 minus 2 times b minus d is equal to 0. So this is our fourth and final equation, and just so there aren't any confusions, I'm going to erase this row right here. Okay, now we've got a nice system of equations, and we're going to go ahead and solve it. So what I can do first is I can subtract the fourth equation from the second equation. Okay, so these terms here will cancel out. So I'll get that minus 4c plus 2d minus 4c plus 2d is equal to 0, or that 2d is equal to 4c, or in other words, d is equal to 2c. Okay? Now, I'll go ahead and plug that in to our equation number 3. So a plus b minus c minus 4 times 2c is equal to 1. Okay? Or in other words, a plus b minus 9c is equal to 1. Now I'm going to rewrite our first equation. A plus b plus c is equal to 0. And I'm going to subtract the second equation, this one, from this one. And these terms will, of course, cancel out. Minus 9c minus c minus 10c is equal to 1. Therefore, c is equal to minus 1 over 10, which would make d equal to negative 1 over 5. Okay, so these are our first two results. Okay, now we want to get to our two other results. So a plus b is equal to negative c. So a plus b is equal to 1 over 10. We get that from equation number 1 right here. And from equation number 3, we get that a plus b is equal to 1 plus 9 is equal to 1 plus 9c. That's what we get from equation number 3. Or in other words, it's equal to, 1 over 10. Yeah, okay, so we're not going to use this one after all. So a plus b is equal to 1 over 10. And now we're going to use either equation number 2 or equation number 4. So from here, we get that a is equal to 1/10 minus b. And we'll plug that into, let's say, equation number 4. Minus 2 minus the square root of 5 minus 2 minus the square root of 5 times 1 over 10 minus b plus the square root of 5 minus 2 times b and minus d plus 1 over 5 is equal to 0. Okay, now from here we can go ahead and find b. First, let's multiply everything by 10. So then we'll get minus 2 minus the square root of 5 times 1 minus 10b plus 10b times the square root of 5 minus 2 plus 2 is equal to 0. And now let's cross multiply everything. So minus 2 times, this is negative 2, plus 20b minus the square root of 5 plus 10 square root of 5b plus 10 square root of 5b minus 20b plus 2 is equal to 0. So we'll get here that, okay, minus 2 plus 20b minus square root of 5 plus 10 root of 5b plus 10 root of 5b minus 20b. Okay, these two cancel out, as do these two. And we'll get that 20 square root of 5 times b is equal to the square root of 5. We can cancel out the square root of 5s. And from here, we get that b is equal to 1 over 20. And from here, that would also make a equal to 1 over 20. Okay, now when we know this, we can rewrite our integral as minus 4 times the integral of a over t minus 2 plus square root of 5, 1 over 20 times t minus 2 plus the square root of 5 plus b over t minus 2 minus the square root of 5 plus c t plus d over t squared plus 1 ct plus d minus 1. Okay, I'll just put down a negative here, minus t over 10 plus 1/5 over t squared plus 1, and of course everything is dt. Everything is multiplied by dt. So we can just go ahead and separate these up into 3 separate integrals, which is the integral of 1 over minus 5 times t minus 2 plus the square root of 5 dt plus the integral of 1 over negative 5 times t minus 2 minus the square root of 5 minus, Okay, this is going to be the same as t plus 2 over 10, t plus 2 over 10, minus, so this is going to be a plus, 4 times the integral of t plus 2 over 10 times t squared plus 1 dt. So the first part here is going to be negative 1/5. These are all now easy to solve integrals of the natural log of t minus 2 plus square root of 5 plus the natural log, minus 1/2 of the natural log of t minus 2 minus the square root of 5, and plus I'll just call this I. Okay, so I'm going to solve that right here. I is this is I. So 2 times the integral of t plus 2 over 5 times t squared plus 1 dt, or 2/5 over times the integral. I'll separate this again, of t over t squared plus 1 dt plus 2 integrals of 1 over t squared plus 1. Of course, this is also dt. So I'll just put in 1/2 here. I'll put 2 here. And now these are extremely easy to solve integrals. 2/5 times 1/2 of the natural log of t squared plus 1, which is always positive, so we don't need the absolute parentheses, plus 2 times the inverse tangent of t, which is, once cross multiplied, 1/5 ln of t squared plus 1 plus 4 over 5 arctangent or inverse tangent of t. So now when we've got our result, we have to go back to this is our complete result. And I is equal to this. Now we just have to go back to the x world. So, in other words, our original integral is going to be minus 1/5 ln of t, which is just tangent of x over 2, minus 2 plus the square root of 5, minus 2 plus the square root of 5, minus 1/5 of ln of tangent of x over 2 minus 2 minus the square root of 5 plus 1/5 of ln of tangent squared of x over 2 plus 1 plus 4 over 5 arc tangent of x squared over 2. So we can just, the arc tangent and the tangent will cancel each other out. So we can just write it down times x over 2. Here we're going to be left with a 2. So this is going to be 2x over 5 in total. Plus 2x over 5 plus c is equal to the integral of 1 over 2 plus cotangent of x dx. And of course we can just go ahead and combine these two out. So, I mean these logarithmic parts, by using the rules of logarithms. So this is going to be equal to 1/5 times the ln of tangent squared of x over 2 plus 1 over the tangent of x over 2 minus 2 plus the square root of 5 times tangent of x over 2 minus 2 minus the square root of 5 plus 2x over 5 plus c. Or when we finally multiply this out, we'll be left with 1/2 of ln of tangent squared of x over 2 plus 1 over, when we multiply out this denominator, tangent squared, we'll get tangent squared of x over 2 minus 4 times the tangent of x over 2 minus 1 plus 2x over 5 plus c. And finally, we can say that the integral of 1 over 2 plus cotangent of x dx is equal to 1/5 times 2x plus, and of course, absolute value right here, plus ln of tangent squared of x over 2 plus 1 over tangent squared of x over 2 minus 4 tangent x minus 1 plus c. So this is our final answer for this example. So I hope you learned something today. And if you enjoyed the video, make sure to subscribe and click on that thumbs up button. See you in the next video. Oh, sorry, my mistake. Instead of x, we should just put in x over 2. So again, this is our final solution to this problem. I hope you enjoyed it, and yeah, I already said the rest. Goodbye.